Naive Bayes classifier. Naive Bayes classifier depends on the basics of probability theory. So here just to cover quickly about the main concepts related to the probability theory. Firstly, if we have an event, we call it random variable x, then we calculate the probability by calculating the number of occurrences divided by the total number of instances. In this case, this is called the relative frequency of events. Again, where you take the number of occurrences for an event, let's say for a feature, the number of occurrences inside the historical data divided by the total number of occurrences. And the probability, as it's known, is between the value of 0 and 1, and the summation, applying summation on probability values, must be equal to 1. Variables that have probability associated with each variable outcome are known as random variable, and this is different than algebraic variable. For example, where you convert between Celsius and Fahrenheit, or where you find an equation you have like 10 plus x equal 13. So in this case, x certainly has a value, right? It's known value. Just we play around the equation, we come up with the final value for x. In other words, this is a deterministic variable. But when we talk about random variable, that means we don't know about the output. For example, like tossing a coin. We don't know whether the coin is gonna is gonna be facing, when it's landed, the head part is gonna be on the top or the tail part. So here we have a doubt in there, right? We don't have a certainty. In this case, we call it random variable. So Px denotes the probability of any generic output of random variable x, while Pxi will be used to represent the probability of a specific outcome. So again, here we're emphasizing that we look for the relative frequency, or what is called frequentist, where you look to the number of occurrences for a value inside the dataset, divided by n, which denotes the total number of occurrences. Joint probability is where you have more than one random variable. For example, we have x and y. In this case, we're not going to look for the number of occurrences for xi, for example, related to x, but of course that means we are going to look for a joint occurrences for x equals xi and y equal yi divided by the total number of occurrences. So for example, like you are looking, what is the probability that there's going to be a surprise quiz today and you will be late, for example. Marginal probability is another type of probability where you have, for example, two random variables x and y, but you marginalize y out. You take it out and then you only focus on finding the probability where x equals to xi. So considering the last example, where you look to the probability of having today a surprise quiz and you're going to be late for the class. Now, if we marginalize out being late to the class, then we can answer the question, which is related to the probability of having a surprise quiz today. We come to a conditional probability. Conditional probability is where you have two random variables, x and y, but you're looking for probability of y given that x has already happened. So again, you can think of it, we have two events, x and y. So you're looking for probability for the event y to occur given that the event x has already occurred, has already happened. So conditional probability can be used for answering what question? Questions such the following: given that it is going to rain today, what is the probability that I will go to the class? Or again, building on the previous example, given that I'm going to be late for the class, what is the probability having a surprise quiz? So again, conditional probability, we have two random variables, two events, A and B. Event A is that an individual applying for college will be accepted, and the chance is 80% that the individual will be accepted to the college, let's say based on historical data. Event B is that this individual will be given dormitory housing only if he was accepted. and dormitory housing will only be provided for 60% of all the accepted candidates. In this case, if we are looking about the probability, the joint probability of being accepted and having dormitory housing, then we can use conditional probability, because if you check, event B is conditional probability. Conditional probability, that what is the probability for dormitory housing giving or having dormitory housing given that the student is accepted, multiplied by the probability that the student is being accepted, then we get the joint probability. So building on all aforementioned ideas or probabilities we discussed, what is Bayes classifier? Bayes classifier is based on Bayes theorem. What is Bayes theorem? Bayes theorem says if you are given the event x, the probability of y is going to be equal to the joint probability of x and y divided by the probability of x, or given the event y, then the probability of x equals to the probability of the joint probability x and y divided by y. Right? This is just the conditional probability that we've seen earlier. Now Bayes' theorem actually substitute these two equations. So given x, the probability of y equal supposed to be the joint probability of x and y, but based on the second equation we can substitute saying that we substitute with another conditional probability. So given y, the probability of x multiplied by the probability of y divided by probability of x. And this is the Bayes theorem. Let's understand further what are these terms. If you check on the right hand side, we have the probability of y given the event x occurred equals to the probability of x given that the event y occurred multiplied by the probability of y divided by px. Now the left hand side, that the one that we are after, we call it the posterior. The posterior, given x the probability of y, which is known as the posterior probability of the target class. Pxy, we call it or measures the likelihood of observing x from the distribution of instances belonging to y. Py is known as the prior probability or the prior knowledge, also you can call it, where we look to capture the probability of y regardless of the situation for x. Okay, so for example, the prior knowledge that the likelihood of any person get accepted regardless whether they got dormitory or not. And how to obtain this value? Either you can get it from expert knowledge or based on the historical distribution of the class label. In other words, based on your data set. Finally, Px is called the probability of evidence, or this is the marginal probability where it doesn't depend on class label. So you can think of it, we have marginalized y, just we are looking into Px, which is the probability of evidence. Let's take an example to understand further. Let's say you got a data set about people, and the data set includes two input features. You have salary and age, and the target variable is whether the person is going to go to work or to office by driving or walking. So in other words, you want to predict, you want to guess whether such a person is going to work by driving or by walking. So in this case, you can see the figure here showing you, we have the green spot, which represent those individuals, the historic data for individuals who have driven to office by a car or by driving, in other words. On the other hand, the red spots, which represent the individuals who actually went to work by walking. And now we got a new data point and we would like to predict. We would like to predict for this new data point whether the person is going to office by driving or walking. Now, in order to find out what it says, the Bayes theorem, or what we're gonna do is we're going to find the probability that the person going to office by walking, given the features, the input feature, which are the age and salary. And also we're going to calculate the probability that the person is going to drive, given that the features for the age and salary. And based on these two probabilities, we find out the final result. and the one that has the higher value, we can conclude then based on the higher value to which class or to which we can predict whether the person is going to go to office by walking or by driving. Let's take an example with numbers and see how this works out. So let's say you like football or soccer, and you are interested to know whether your team is going to do a match, is going to play while the weather is sunny. So in other words, we're going to validate such statement that the football players, for example, will play if weather is sunny. We're not sure. So we can apply the Bayes theorem, which is based on the conditional probability. So first, what we do, we can go and find, so let's say here we have the data set based on the history of matches for your team and the weather. So weather is the input and the target is play. So we go and find out the frequency table, just we like summarize our historic data. So we have the weather based on the historic data. We have three types of weather, either it's overcast or rainy or sunny. And here we have the distribution, whether the football players or the soccer players have played the match or not. Now we come to finding the posterior probability. We are after finding the posterior probability. In other words, you are going to find whether the football players are going to play in such a sunny weather or not. So what you need to do, you need to find two values. What is the probability that the players are going to play given the weather is sunny, and what is the probability the players are not going to play given the weather is sunny? And then you weigh out, you find out which probability is higher. Then you can decide based on the higher value, you can decide whether the team are going to play or not. So given the Bayes theorem, in this case, we're going to calculate the probability the players are going to play given the weather is sunny is equal to the likelihood probability, right? The weather is sunny given that the players have played, multiplied by the prior knowledge, P, the probability the players have played, divided by the probability of being the weather sunny, okay, the evidence. So here, taking the first term, the probability that the weather is sunny given that the players have played. So based on the likelihood table, you will see that the players have played 3 times out of total 9, because given this is conditional probability given the players have played. So only you need to check on the cases where the players have actually played, and given the probability, or sorry, given the situation the weather is sunny. So simply we have 3 times divided by the total number of matches where the team have played. So 3 divided by 9. Next, what is the probability that the weather was sunny among these 14 incidents? So we had 5 incidents where the weather was sunny, divided by 14, of course, the total number of incidents, regardless whether the team players have played or not. Finally, PS, same thing. So how many times the players have actually engaged in the football match, divided by the total number of incidents, the total number of data points or objects we have in the historic data, which is 9 divided by 14. Now just we substitute inside the equation and we get that they got the chance is the 0.60. Right? So we have 60% probability that the players are going to play for the match. Same idea you apply for P, finding the probability the football players are not going to play given the weather is sunny. So same idea, you go and calculate the probability of sunny given that the players didn't play, multiplied by the probability of sunny, and divided by the probability of no. Multiplied by probability of no divided by probability of sunny. So probability of no, the number of incidents that the players didn't go into the match or didn't play. So we have how many in this case? For they didn't go, we have 5 divided by 14 total incidents, and finally divided by same probability for sunny. Then we get 0.36. So weighing or checking, comparing these two figures, we find out the probability of yes given the weather is sunny is higher than the probability of no given the weather is sunny, and then we can conclude that the football players are going to go to play even if the weather is sunny. In other words, the statement above is correct. Players will play if the weather is sunny.